Hello class, today we're going to look at Chapter 10, Section 6, number 14 in your study plan. We're going to be solving a logarithmic equation, and we have log base 3 of 2x plus 1 minus log base 3 of x minus 3 equals 2. Now what we want to do is we want to notice that we have two logs in our equation. We want to try to condense these down to a single log. We check out the bases. We have a base 3 and a base 3, so that's telling us that we can use some of our properties like the product property or the quotient property. If we're going from two logs to a single log in subtraction, this is going to be our quotient property. So we're allowed to crunch these back together using division. So let's go ahead and look at how to solve this. So my first step is to take these two logs and make them into a single log. Again, this subtraction sign of the same bases tells me that I'm working with a division. So I have log base 3 of the numerator, which is the first log, 2x plus 1, divided by the x minus 3. This is still equal to 2. So notice now that we have log base 3 of 2x plus 1 divided by x minus 3 equals 2. So we've created a single log. Next step is to change this into exponential form. So I'm going to take the base to the power of the solution here, and it's going to equal this value inside. We're going to take 3 to the power of 2 equals my whole chunk that was in here. So 2x plus 1 equals x minus 3. So by converting to exponential form, we've eliminated the log in our equation. So now this is an equation that we can use some of our rules that we learned earlier in the class. So let's just go ahead and start breaking it down. 3 squared is going to give me 9. Equals 2x plus 1 over x minus 3. Now I don't want a variable in the denominator, so I'm going to go ahead and multiply that whole expression out. So we're going to multiply by x minus 3 on both sides. So what this will do is this will eliminate the x minus 3's here. So these are going to cancel out. And it's going to leave me with the left side here. If you would rather have the 9 in front, if that looks more familiar to you, you can write it up front. Go ahead and distribute. Get 9x minus 27 equals 2x plus 1. And start combining like terms by moving everything over. I'm going to take the 2x over, so minus 2x. That's going to give me 7x minus 27 equals 1. I'm just going to move that up to the top of the page. And then I'm going to go ahead and add the 27 over. And we get 7x equals 28. And the last thing we have is divide by 7, divide by 7. And we get x equals 4. So you can see that at the beginning of the problem, we used our property of logarithms to get it down to a single log. And then we took our single log, converted into exponential notation just to get the log out of the problem. Then from here on out, it was using our tools from solving equations before. Now before we classify this as the actual answer, we do want to verify that it's a possible answer. So we want to plug 4 back into the inside for x. So I would have 2 times 4 plus 1. 2 times 4 is 8 plus 1 is 9. So I'm looking for, make sure that these are positive values. We're not allowed to have a negative number left over inside. And then we check the other ones. We have 4 minus 3, which equals 1. Okay, so we're good. As long as they both produce positive numbers, then they're possible solutions. So x equals 4. Let's go to our study plan. And I'm going to plug in a value of 4. Notice the x equals is already there. So I don't want to waste all that work and accidentally plug in x equals 4. Just plug in the 4. And we'll check our answer. Nice work. Okay, so that was solving an equation where we have logarithms in it. I hope it was helpful.